A gas stove clicks, sparks once, and produces a small blue flame that appears instantly and burns cleanly until it's switched off. That flame is fed by a fuel that formed underground over millions of years, refined by machinery and delivered through a network of pipes most people never think about. The strange part isn't the technology, it's the fact that this relationship between humans and underground fuel is not new at all. Long before anyone understood chemistry, geology, or combustion, people were already collecting this substance, burning it, building with it, and in some places worshipping the ground it came from. That raises an obvious question. How did people who had no idea what oil actually was manage to find it, recognize what it could do, and start using it thousands of years before the first drilled well? The answer doesn't begin with a single discovery. It begins with the ground itself doing something unusual. Where the ground leaked, in several regions of the ancient world, crude oil and its byproducts did not stay buried. Along parts of the Tigris and Euphrates river valleys in what is now Iraq, thick black tar seeped naturally out of the earth. Around the city of Hit on the Euphrates, springs of this material have been active for so long that geologists studying the region describe it as one of the oldest continuously flowing bitumen seeps on the planet. People didn't need to dig for it. It came to the surface on its own, pooling, hardening in the sun, and sometimes catching fire when gas escaping from the same cracks ignited. This is the starting point for the story, because it explains something important. Ancient humans didn't invent petroleum use out of nowhere. They inherited a resource that was already announcing itself, visibly and sometimes audibly, in a handful of specific places on Earth. The earliest large-scale evidence for people actually working with this material comes from southern Mesopotamia, where the Ubaid culture settled marshy floodplain land as early as roughly 4,500 BC. These communities built houses out of bundled marsh reeds, a practical solution in a landscape without much timber or stone. Reed walls, however, don't hold up well against seasonal flooding. Researchers studying the material culture of the region have found that mud coatings alone left these structures vulnerable to water damage. Bitumen changed that. Coated over reed bundles, it created a waterproof seal that mud could not provide on its own. This is where the story could easily flatten into a simple line. Something like, ancient people found tar and used it to waterproof things. But the archaeological record shows something more interesting. The material didn't stay at one use. It spread outward into nearly every part of daily and monumental life across Mesopotamian civilization for the next several thousand years. From patch material to empire-scale infrastructure. By the time of the Sumerians, and later the Babylonians and Assyrians, bitumen had become a structural material on a massive scale. At the Ziggurat of Ur, one of the oldest surviving temple complexes in Mesopotamia, archaeologists have documented bitumen used as mortar between layers of baked brick. The same substance sealed royal tombs, held mosaic inlays in place, and coated the hulls of reed boats that carried goods and people along the Euphrates between cities like Hit and Nippur. Researchers working on Sumerian bitumen composites have gone further than simply confirming that the material was used. A team analyzing dozens of archaeological bitumen samples using digital microscopy found evidence of standardized formulations, meaning specific mixtures tuned for specific jobs rather than raw tar applied without preparation. That detail matters because it shows something beyond convenience. People were experimenting with additives, adjusting texture and durability, and repeating successful recipes. That is not accidental use. That is applied material science, conducted without anyone involved having a word for chemistry. The scale of demand also explains why one particular location became so important. Sumer had very little accessible timber or building stone, so a reliable waterproofing and binding material became essential infrastructure rather than a luxury. The seeps at Hit supplied enough of it, consistently enough, that the site itself took on outsized cultural significance. The Assyrian king Tukulti-Ninurta II recorded camping near the bitumen springs of Hit during a military campaign in the 9th century BC, describing the place as one where the gods speak. Centuries later, the Greek historian Herodotus wrote about the same springs, describing asphalt rising from the water near a small river connected to the Euphrates and being transported to reinforce the walls of Babylon. That detail about God's speaking is not an isolated bit of color. It points to something the Mesopotamians actually experienced and could not otherwise explain. A sound with no obvious cause, bitumen seeps are often accompanied by escaping natural gas. And that gas sometimes makes noise as it forces its way up through cracks in rock and soil. Researchers studying Mesopotamian material culture have noted that the muffled sounds coming from bitumen deposits were interpreted by people at the time as the muttering of underworld gods. There was no way without modern instruments to identify pressurized gas moving through porous rock as the cause. The explanation that made sense given the available evidence was a supernatural one. This detail reframes the entire subject. Ancient petroleum use wasn't only a material story, it was also a sensory experience. A place that oozed dark liquid, occasionally caught fire without any visible ignition source, and produced sound from underground. In a world without geology as a discipline, treating that place as sacred was not superstition layered onto a practical resource. It was a coherent interpretation of genuinely strange physical evidence. That same pattern, unexplained fire rising directly from the earth, shows up again a considerable distance to the east, in a region that would eventually become central to an entire religious tradition. Fire that never needed fuel. On the Absheron Peninsula, near modern Baku, in present-day Azerbaijan, natural gas escaping through fissures in the ground has ignited on contact with air or lightning for an extremely long time, in some spots burning without pause. Unlike a campfire or an oil lamp, these flames required no one to feed them. They simply continued. For the Zoroastrians of ancient Persia, fire held deep religious meaning as a symbol of divine purity connected to Ahura Mazda. A flame that sustained itself indefinitely, emerging from bare ground, was not treated as a curiosity. Sites where this occurred became centers of pilgrimage, and fire temples were constructed around them. Excavations near one of these sites, the Maiden Tower complex in Baku's old city, have revealed an altar containing traces of both oil and fire residue, consistent with a basin that was deliberately kept filled with oil to maintain a continuous flame. The nearby site, now known as Yanar Dag, meaning burning mountain, still produces flames several meters high from a thin band of porous sandstone, fed by steady gas release from below. Here the evidence supports a clear distinction between what is established and what remains uncertain. It is established that natural gas seeps in this region ignite on their own, and have done so for a very long time. It is established that Zoroastrian religious practice placed enormous importance on continuously burning fire. What is harder to pin down with precision is exactly when organized fire worship first attached itself to this specific landscape, since the surviving temple structures at Baku date mainly to the 17th and 18th centuries, even though textual and archaeological hints point toward much older, pre-Islamic use of the same fire sites. The pattern across both Mesopotamia and the Caucasus is the same. Petroleum and natural gas entered human culture first as something encountered, not something sought out. But that changes once a very different, much more practical problem enters the story, thousands of kilometers away in what is now southwestern China. When digging for salt hits something else, salt was one of the most valuable commodities in the ancient world, essential for preserving food and for basic nutrition. In the Sichuan basin, a region that was once covered by an ancient inland sea, salt exists underground in the form of brine, salt water trapped in rock. Around 2,250 years ago, workers in Sichuan dug the first recorded salt well in China, adapting existing water well technology to reach brine deposits instead. That basin geologically does not contain only brine. It also sits above natural gas. Engineers and historians studying the region's drilling history have noted that well diggers sometimes fell ill while working, an effect now understood as gas exposure and at the time interpreted as an encounter with malevolent spirits. Eventually, someone recognized that the same gas that made workers sick was flammable, and that recognition turned a hazard into a resource. Chinese engineers developed a system of bamboo pipelines to carry the gas away from wellheads to centralized boiling stations, where it was burned to evaporate collected brine and extract usable salt. This is a clean example of a chain reaction changing a whole industry. A resource, brine, required extraction. Extraction ran into a second resource, gas, initially treated as a danger. Recognizing the gas as fuel solved a separate problem, namely the enormous amount of fuel needed to boil water down to salt at scale. Solving that fuel problem allowed salt production to expand, which in turn justified deeper wells, better pipelines, and more advanced drilling technology. By the early centuries AD, Chinese well drillers had refined percussive drilling techniques capable of reaching roughly 140 meters. Around 1050 AD, solid bamboo pipe was replaced with a lighter, flexible bamboo cable system, which reduced the weight that needed to be lifted from deep wells, and allowed drilling to go significantly deeper. By the 1830s, one well at Sichuan's Ziggurat Basin, a major center of this industry, reportedly passed 1,000 meters in depth, a milestone that predated comparably deep wells anywhere else in the world by decades. None of this began as an attempt to develop what would later be recognized as a petroleum and natural gas industry. It began as an engineering solution to a salt problem, and the fuel came along as a byproduct that someone had the sense not to waste. A revealing complication in Egypt. There is a detail buried in the history of ancient Egyptian mummification that overturns a long-held assumption, and it's worth pausing on because it shows how easily a good story can outrun the actual evidence. The English word mummy traces back through Arabic and Persian to mumia, a term referring to bitumen. That etymology exists because European travelers and early scholars, working centuries after the practice had ended, assumed that black, resin-coated Egyptian mummies were preserved primarily using bitumen, the same substance so heavily used in Mesopotamia. For a long time, that assumption simply stood unchallenged. Modern chemical analysis tells a more complicated story. Researchers Stephen Buckley and Richard Evershed, publishing in Nature in 2001, examined organic residues from a large collection of provenanced Egyptian mummies using gas chromatography and mass spectrometry, techniques capable of identifying specific chemical fingerprints left behind by plant resins, animal fats, beeswax, and bitumen. Their results, along with later work by Kate Clark, Salima Akram, and Evershed, published in 2016, indicate that bitumen does not appear in Egyptian mummification balms until roughly 900 BC, well after the era typically associated with the most elaborate and best-preserved mummies. Earlier balms relied mainly on plant oils, animal fats, beeswax, and various resins, not the tar that gave the practice its eventual name in other languages. This is the kind of finding that a script built purely on stated assumptions would never catch, and it earns its place here because it changes the meaning of the whole example. The connection between petroleum and Egyptian mummification is real, but it is a late addition to a much older practice, not a technique the earliest embalmers inherited from Mesopotamian bitumen culture, as the word mummy seems to imply. Language preserved a misunderstanding that chemistry, thousands of years later, was able to correct. What ties these places together? Mesopotamian bitumen use, Persian fire worship at gas seeps, Chinese salt well gas piping, and the later addition of bitumen to Egyptian embalming don't share a common inventor, a common date, or even much direct contact with each other in their earliest phases. What they share is a pattern. In each region, people encountered a naturally occurring form of fuel or tar, observed what it did, tested it against a real problem they already had, whether that problem was a leaking reed wall, a religious need for enduring fire, or a fuel shortage during salt production, and then kept using it because it worked. None of these traditions required understanding that petroleum, bitumen, and natural gas are all products of the same underlying process, organic material transformed by heat and pressure over geological time. That understanding came far later, arriving with 19th and 20th century geology and chemistry, long after the practical relationship between humans and these substances had already been running for thousands of years. It's also worth being honest about what the evidence doesn't allow anyone to claim. There is no way to identify the first person who scooped bitumen off a seeped hit and decided to coat a reed wall with it. There is no way to know whether the practice began once and spread, or whether different communities in the same wet, timber-poor floodplain arrived at the same solution independently, since reed construction and nearby tar seeps existed together in more than one Mesopotamian settlement. The archaeological record preserves the result, not the moment of realization, and honest researchers working on this material are consistent about saying so. What the record does preserve is a very long, very gradual relationship, stretching from an oozing riverbank in Mesopotamia around 4500 BC to a burning hillside in the Caucasus, to a brine well in Sichuan, to a chemistry lab analyzing 3,000-year-old embalming residue. In every case, the fuel was already there, doing something strange and visible long before anyone had a framework for explaining why. That gas stove flame, then, isn't really a modern invention meeting an ancient mystery for the first time. It's the same relationship people were already managing without any of the science, sealing boats with it, worshipping it, boiling brine with it, occasionally misnaming an entire funerary tradition after it, thousands of years before anyone thought to ask where it had actually come from.
If you enjoy learning about topics like these, make sure to subscribe for more. And if you enjoyed this video, don't forget to leave a like and share your thoughts in the comments. I'd love to hear what you think.